Hello, this is Math 2270 coming to you from the College of DuPage for summer 2020, and this lecture is the conclusion of. Now, last time I left you working on this problem. I hope perhaps you finished it, but if you didn't get a chance to work on it, we certainly can let you know what you need to do now. So give it a go, and let's see how you did. This is a Clause's equation, but the f is the square root of t squared plus 1. Since this is a Clause's equation, we know that the general solution is y is equal to a constant times x plus, and this is f of that constant, which is going to be c squared plus 1. So this family of lines is the general solution. Now, there was another solution that was described by x of t is equal to minus f prime of t. If I take the derivative of f of t, I get 1/2 this business to the minus 1/2 times the derivative of what's inside, which is 2p. The 2's will cancel out, and we get x is equal to negative p over square root of p squared plus 1. Now, to find the corresponding expression for y, we take this expression for x, we realize that y prime is p, and we substitute into the original Clause's equation. Doing it here, we get this. Notice that's p squared now, plus this. And now what we're going to do is get a common denominator. So we get the common denominator, and we realize that when we get the common denominator, these two things cancel. So this is 1 over the square root of p squared plus 1. So the parameterization is going to be x is equal to minus t over the square root of t squared plus 1, and y is equal to 1 over the square root of t squared plus 1. But that parameter can actually be eliminated from those formulas. If we square this one and square this one and add them together, we get 1. So that means that the singular solution here is a circle, not a line, with radius 1 centered at the origin. And here we see the lines and the envelope graphed. Here's another one. You know what to do. Let's see how you do. Well, this time the f is the natural logarithm of t, and so that means that our general solution is going to be y is equal to cx plus the natural logarithm of c. The slope is going to be c, the intercept is going to be the natural logarithm of c. But x for the singular solution is going to be minus f prime of t, and so that's going to be minus 1 over t. And so then y, I will substitute in here, I get x times minus 1 over x gives me minus 1 plus, and this is the ln of t. Now I can eliminate that parameter by substituting back in. You see, if x is minus 1 over t, then t is minus 1 over x. So I can just substitute in there. Here I'm using a property of logarithm to change this sign. And I do have to worry about the interval of validity. But this is the singular solution. This is a logarithm curve. This is a line. They are not part of the same family. In closing, now more than ever, time is precious. Each day must count. Do the math. It will make you strong. And now, more than ever, take care of yourself and of each other. God bless.